I replaced a $500 a month API bill with a single $800 GPU. Yep, you heard that right. Today, I'm going to show you exactly how developers are completely changing their AI stack in 2026, and honestly, what nobody tells you about running local AI. Let's start with a painful reality that I know a lot of us are all too familiar with. $500 a month. That is a pretty typical API bill right now for a developer or maybe a small team who's basically renting intelligence through services like ChatGPT Pro or Claude Pro. And that's not even counting all the API calls running in the background for your actual apps. Over a single year, that is $6,000, just gone. You are effectively renting your brain power on the cloud, and because that meter is always running, it completely limits how much you can actually experiment and build. But there is a surprisingly simple alternative. I completely wiped out that agonizing recurring fee with a single, one-time hardware purchase. Just an $800 used GPU. That's literally the whole shebang. Within just a couple of months, that hardware totally paid for itself. No more API limits, no more rate limiting telling you to slow down, and absolutely zero data ever leaving my local machine. So here's exactly how we'll guide you from theory to deployment today. We're going to hit the local AI revolution, hardware tiers and costs, the best models by use case, how to set up in 10 minutes, local versus cloud AI economics, and finally, your personalized decision matrix. Let's get into it. Okay, let's dive into section 1, the local AI revolution, covering privacy, cost, and speed. Look, I want to weigh the real trade-offs up front here, because let's be real, building infrastructure isn't magic. There is work involved. But the pros? They are massive. We're talking 100% data privacy, your proprietary code, your internal documents. They never leave your local network. You also get this blistering 20 to 60 millisecond LAN latency, full offline use, and a fixed cost. Now, on the flip side, the cons are the upfront hardware cost, plus you're on the hook for setup and maintenance. But ultimately, having absolute data sovereignty, plus that instant 20 millisecond response time for agentic coding workflows, it's an absolute game changer. Moving right along to section 2, hardware tiers and costs, and what you actually need to buy. It is time to dismantle the myth that you need some $20,000 server farm humming in your basement to run high-quality frontier AI. First, you just need to understand the golden rule of local AI. Video RAM, or VRAM, is your primary bottleneck. Compute speed is actually completely secondary to how much memory your graphics card has. And thanks to an incredible software technique called Q4 quantization, we can compress these massive models to fit on normal consumer hardware. To put that into perspective, the data shows that running a model on a 5-year-old GPU using Q4 quantization gets you 96% of the quality of an insanely expensive A100 data center card. It's just a tiny bit slower, but it still outputs at 20 to 40 tokens per second, which, by the way, is way faster than you can even read. Now, you might want to grab a screenshot of this. This is the concrete dollar amount hardware matrix. You absolutely do not need the newest shiny tech to get in the game. A used RTX 3060 with 12 gigs of VRAM gets you in the door for around $200. But the absolute sweet spot, the ultimate value, is the used RTX 3090. It has 24 gigabytes of VRAM and runs around $700. That card unlocks almost every major open-weight model out there right now. Oh, and if you're in the Apple ecosystem, the unified memory on Macs is incredible. A Mac Studio M4 Max is just an absolute beast for running huge models locally. All right, section 3, best models by use case. Let's look at the arsenal. We are going to look at the specific AI engines you'll actually be deploying. Because here's the thing, one size does not fit all. There is a clear, undisputed winner for different development tasks. For your daily driver, the overall champion is QN 3.6 27B. Just look at these benchmark numbers for a second. It has a staggering 45.8 intelligence index and an incredible 94.2% agentic task completion rate on the Tau2 benchmark. Basically, it's the zero-shot agentic coding champion. It can architect and write complex, actually working code on the very first try. Plus, it gracefully handles a massive 64K context window while fitting perfectly onto a 24GB GPU. But what if you were doing purely technical work, like complex scientific reasoning or strictly pure code generation? Then Gemma 431B is your clear victor. It boasts a 38.7 coding index and hits the highest GPQA score at nearly 86%. It also has incredibly stable context cliff performance. That basically means it won't just suddenly degrade and start spitting out gibberish when you feed it a massive, dense code base to analyze.
I want to rapid fire a few alternate choices here too, just so you have the complete picture. And we're looking at real benchmark numbers here to prove this is concrete data, not just vibes. If speed is your absolute top priority, the Quen 3.635B A3B is a total speed demon. We're talking 65.6 tokens per second. If you need complex logic and software architecture, DeepSeek R1 Distill is the absolute king of thinking models. And hey, if you were lucky enough to have 40 gigabytes or more of VRAM, Llama 3 3070B brings literal enterprise-level intelligence right to your local desk. This is another great one to screenshot. This chart brilliantly illustrates exactly how much memory you need based on the model size, assuming you're using that Q4 quantization we talked about. As you can see, a 12-gigabyte card comfortably runs a 14 billion parameter model, taking up about 9 gigs of VRAM, which leaves you a nice little buffer for context. A 24-gigabyte card, that gives you plenty of headroom to run the heavy hitters in the 27 to 32 billion parameter range, while still leaving space for your operating system and web browser to run smoothly. Okay, section 4, setup in 10 minutes, going from zero to inference. So you really have two top-tier engines at your disposal for getting this running. If you are a developer actively building apps, Ollama is 100% the way to go. It's a CLI-first tool that exposes a super seamless REST API. It just runs as invisible infrastructure in the background, meaning your code can talk to it the exact same way it talks to OpenAI. On the other hand, if you're a visual learner or you just want to poke around and explore models without opening a terminal, LM Studio is fantastic. It gives you a beautiful desktop GUI for instant visual parameter tuning. Let's actually walk through the 3 simple steps to spin up a local Ollama instance, just to prove how easy this is. Step 1. Install Docker Desktop and allocate at least 8 gigs of RAM. Step 2. Open your terminal and run the background container by typing Ollama run qn 3.627b. It automatically downloads the model and fires up the engine. Step 3. Just point your existing code or your coding assistant to localhost 11434 instead of the OpenAI URL. And that's it. DLL hell is literally a thing of the past. Let's move to section 5, local versus cloud AI, and the real economics behind this. I really want to challenge you to look at the total cost of ownership at scale here. Because what's really interesting about this data is the math. This graph from Lenovo's sizing guide compares sustained inference on an on-premise hardware config versus a cloud instance on AWS. The disparity is just wild. You are looking at $4.74 per million tokens on-premise, compared to a steep $29.09 in the cloud. That is a massive 84% cost advantage when you run sustained workloads on your own hardware. But, we have to be totally honest about the break-even point here. If your app is running less than 1 million tokens a day, just stick to the cloud API. Honestly, the hardware will just sit idle too often to justify the upfront cost. However, the very second your daily volume crosses that 2 million token threshold, local AI pays for itself in just a matter of months. Which brings us to our final section, your decision matrix. If X, run Y. Let's summarize all of this into an exact blueprint. If you are on a tight $200 budget, grab a used RTX 3060 and run Qwen 2.514B. For the absolute best value, around $700, get that used RTX 3090 and pair it with Qwen 3.627B. If you are integrating AI directly into a developer app, use Ollama as your API backend. And if you're tackling extreme logic or software architecture, you're going to want to run DeepSeek R1. I want to end on this provocative, kind of drop the mic thesis to really leave you thinking today. Don't rent intelligence. Own it. Cloud AI will be dead for devs in 2 years. Seriously, when local hardware offers 20 millisecond latency, absolute data privacy, and completely wipes out your recurring API bills, why would you ever continue to rent your brainpower? Let me know what you think about this massive shift in the comments below. Thank you so much for exploring this with me today, and I'll catch you in the next explainer.